Okay, so the next problem is, again, this is a science problem where the work done to compress gas is given by the change or the area underneath the pressure as a function of volume graph times the change in the volume. So there's our pressure as a function of volume. Okay, it's an inverse proportion. Okay, so if I want to find out the work done, I want to calculate this integral. So the work, I think that's what we're calculating here. Yeah, work is equal to from pressure of 20, I guess that would be in inch pounds or something like that, to 2. The pressure function is 1000 over V times dV. Okay, so all we're going to do is just integrate that function, and we end up with log of, it's going to be 1000 log V from 20 to 2. Okay, so I just plug that in. The work done is 1000 log 2 minus log 20. Okay, so that's going to be 1000 log 1 over 10. Yep, so that's what it is. So I start at 20 from 20 cubic inches to 2 cubic inches. So what I'm going to get here, the function, but the work done is going to be, where's my log done? Log I'm getting negative 2302.58. Okay, and inch pounds is the work units that I'm getting here. Okay, the resistance proportional to velocity. Okay, so when we are moving through some fluid, an air we consider fluid, the resistance is proportional to velocity. So as the faster you go, the more the resistance that you're going to have. Okay, so the resistance is mass times acceleration. Okay, and it's velocity, it's constant times velocity. And we're going to assume that mass is constant here. Okay, and we're going to separate and integrate this expression. So here we want to separate our V. The V is a variable in this case. M and K are constant. So I'm going to rewrite this differential equation in this form. I'm going to bring the V over here, and I'm going to move the M over to that side and the dt to that side. I'm going to integrate both sides of this. So I'm going to end up with log V is equal to negative K over MT plus C. Solving for V, I get e to the negative k mt plus c. Now, I want to solve for that plus c, but I want to rewrite that because that plus c, we can just write it as e to the c, and that becomes our multiplier times e to the negative k over mt. Okay, and we can just get rid of that as that is essentially a constant. So in this problem here, we want to find the initial velocity. Well, if I plug in t is 0, that's going to be equal to 1. So my initial velocity ends up being that e to the c. Okay, so my velocity as a function of time works out to be, that becomes our initial velocity, v naught, and then there's the rest of our equation. E to the negative k over m, which are constants, times t, which is our variable.